The brakes that come with a factory road car do great when on the road. When you take your car to the track, brake cooling is something that always needs to be considered. It's really rare to have a factory braking system that can deal with the temperatures generated on track. The primary consideration when looking at brake cooling is for safety and reliability of the braking system, although the performance of the brakes is also closely linked to the operating temperature of both the disc and the pads. In a motorsport application, the primary method for cooling the brakes is by using external cold air sourced from outside the car and directing it towards the discs. Here we've got a well-used motorsport disc. This is the front face, and this is the area where the wheel would attach to the car on this face here. The shape of this disc means that the air actively wants to travel through the inside of the disc, which is what is giving us our cooling. Once the air has passed through the disc, it exits out through here and finds its way out through the wheel and into the outer stream. The style of these vanes and how open the wheel is and the wheel design actually can have quite a big impact on how well the brakes are cooled. Here we've got a relatively typical example of how a brake duct would attach to the upright of the car to feed air to the disc. This particular plate has an area cut out of it for where the brake caliper and everything sits, which tends to seal this part of the disc, and it's also not quite the right size, but normally this plate would extend to cover that full inside face of the disc and also block off this area. We would have a hose connected to this duct, and we can see how the air is going to flow in from that duct and into this area of the disc, which is where we want to direct the airflow to get these vanes working. It's pretty important when designing this whole system, make it the easiest path to get in once the air is in here to pass all the way through. What we don't want is to have air being ducted to this area and then not doing a good job of sealing it in here. Once the air is in, we want it to be forced into these vanes and to help it pump out through the disc. The layout of the suspension, where your brake caliper sits, how the upright packages with the rest of this duct will determine the exact shape of this. But essentially we want as much as practical for this whole surface to be relatively sealed, so when we send air in here, it's forced to go out where we want it, out through these vanes. One of the critical elements when designing a brake cooling system is the sizing of the ducts, or the area of air you're passing air through into the section of the disc. It's not unheard of in professional racing, certainly in large heavy cars designed for really high speed, to have 3-4 inch ducts, or even multiple 4-inch ducts of air feeding air into this area of the disc to maximize the cooling. One of the challenges with connecting an air source to anything that's part of the suspension is that, particularly on the front, not only is the suspension going up and down, but you've also got the front wheels turning. This particular style of hose is designed for motorsport brake cooling. It does need to have quite a high temperature rating to be able to survive in a high temperature area like the brakes. It also needs to be able to have a decent amount of articulation. It is worth spending the money on getting good quality hose to do this job. Trying to cut corners on the hose is not a great idea because it is quite a hostile environment for the duct to work. This is an example of a way a brake duct system can be packaged on a car. So we've got some ducting hose connecting to this vent at the front area of the car. You can see this travels through, is bolted to the chassis here, runs behind the suspension and connects to this duct, which is bolted to the back of the brake disc. As you can see here, the duct has to go through quite a strange shape. It keeps a constant cross section, but it does flatten in. That's because when the wheels are turned, the tyre will be in this area, so you need enough clearance for the brake duct to pass through without the tyre actually coming in contact with any of the duct. It's actually quite a big challenge to package all of the ducting on the inside of it in a guard like this. Space is always at a premium. As we can see here, there's not a lot of room, particularly when you allow room for all of the suspension to move up and down, in and out as it needs to. And you don't want the brake duct coming into contact with any suspension components because it will chafe and eventually you'll get a failure there. When you're looking for a place to feed that cold air from to cool the brake system, it is pretty important to consider where you take it from at the front of the car. Wherever you take your cold air from, you need to try and take it from as high a pressure area as possible. That usually means somewhere on the front face of the bumper where you've got a relatively direct line in for the air to go. When sizing these ducts, you typically want to go on the larger side than the smaller side. The reason is with different ambient conditions or how closely you're following other cars on track, it will change your brake cooling requirement. So what you typically do is start with quite a large duct and you blank it down to the conditions of the day. So if you start with a 3-inch duct, you may, if it's mounted to the front of the car, that can be as simple as adding tape across the face to allow more or less airflow into the duct, or it can be more sophisticated with pre-cut sections that quickly can be swapped in and out of the front of the duct to tune your blanking. If you're using aftermarket brakes, your brake supplier will be able to give you the ideal operating window for your brakes. That will be a minimum and a maximum temperature, the minimum being the temperature the brakes need to be at before you can start using them hard on track, the maximum being the highest safe operating temperature for them, and in the middle is where you want to be operating all the time when you're racing hard on track. There are a few different ways you can measure the temperature of the braking system. Usually that means checking the temperature of the disc. Most often this is done with infrared temperature sensors of the disc surface or with brake temperature paint. I'll show you what that's about now. So here we've got an example of an infrared temperature sensor. This particular one is a Izzy Racing sensor. In the front surface is where you've got the infrared sensing element, and the idea is it is packaged close to the disc and looking at the disc surface. The manufacturer of the sensor will give you a working range for how closely it needs to be packaged to the disc and what the operating window is. This particular sensor has a 60-degree window where it can sense temperature, so that means from the surface of the temperature here, you draw a 60-degree arc out from the face. That 60-degree window will define the proximity the sensor must be within the disc for it to be able to see the entire disc surface. A more old school but certainly very effective and still relevant way of checking your brake disc temperatures is by using temperature paint. The idea with this is this paint changes colour at a certain temperature range. So in this case, the green will change colour at a lower temperature and the red will change colour at a higher temperature. It's really only giving you a single point of information. When you run the car on track, once this has changed colour, it's not going to change again, but at least it gives you a read on the approximate operating temperature you've got on track to see if you're wildly below or wildly outside the window. What's typical is your brake supplier will tell you that the brakes must be hot enough that they're operating such that the green paint starts changing colour, but that the red would not. So that is your safe window. So if you know if the green hasn't changed colour, the brakes are running too cold, and you might need to reduce the amount of cooling, like adding blanking, or alternatively, if they're running too hot and the red is changing colour, you need to find a way to cool the brakes more for the brakes to work effectively and safely.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.